Hello friends, and welcome back to my channel. Thank you for always choosing to learn through us. In today's tutorial, you're going to learn something new. And if you're new to this channel, I say a very big thank you for learning with us today. Stay back for you have something new to learn. Now, can you answer this question? If you can, just pause for a while. If you cannot, let's do it together. Okay. In today's tutorial, I'm going to show you how to differentiate rational expression using the power rule. Rational expression using the power rule. Now, what do we mean by rational or rational expression? The word rational is taken from the word ratio, meaning it is x over y. That's, you are having something in this form, where you have the numerator and you also have the denominator. So any function that or any expression that has numerator or denominator is said to be in a rational form. I hope you got that. Noted. Now the next thing you need to know is which one is the power rule. What do we mean by the power rule? The power rule says if you are given y as x to the power of n, that dy dx is equal to you multiply and you take away. So we are going to use the power to multiply. So we have nx, then you take away 1 from the power. When you do this, it is said to be the power rule. I hope it's cleared. Okay, now that you understood that, now let's see how we can differentiate this. But remember, since we are making use of power rule, you have to make sure that that rational expression is in all true index form. Is a straight line function or expression that will no longer have a denominator. I hope you got that. So we are going to force this expression in such a way that there will no longer be a denominator. Until you do that, you can now differentiate. Because when you look at the power rule, there is no denominator in the power rule. I hope you are getting what we are saying. So let's see that. But before then, I'll ask you a question. Is this expression the same as this? Is it the same as this? Is this the same as this? Remember, these two are both rational expressions. We can use power rule in this, but we cannot use power rule in this. Make sure you stay till the end. I will show you why. Okay, now let's go to what we have. Let's keep this and answer what we have. Okay, what we have here means that our y is equal to 6x to the power of 4 minus 5x to the power of 3 plus 2x all over 3x to the power of 2. I hope you are still with me. So what do we do here? To ensure that there will no longer be a denominator, we are going to divide each term of this particular numerator by the denominator. So let's do it now. So we're going to clean this off so that you divide this by 3x to the power of 2, because this is the LCM of both the terms in the numerator. So it's the same as writing it this way. I hope you're getting what we're saying. This is the same as this. Okay? So what do you do next? We simplify. Remember, when you have x to the power of 4 over x to the power of 2, it means x times x times x times x divided by x times x. So x will cancel. We are left with x to the power of 2. So it means that when we reduce this, 3 here, 1, 3 here will give us 2. So we have y is 2 to the power of 2x to the power of, this will give us 2, okay, minus, this will give us 5 over 3x, according to your, this is x to the power of 3, means x times x over x times x, okay, x squared means this. So if you cancel, we are having only 1x. Then for this, what do we have there? We have 2x over 3x squared which is 2 times x over 3 times x. This will cancel, so we are left with 2 all over 3x. I hope you are following. Now, when you have 2 over 3x, we want also to still make this 2 over 3x to be, so that the value of this x will have an index. So to do that, we're going to have 2 over 3x is the same as 2 over 1 multiplied by, 2 over 3 multiplied by 1 over x. This is the same as this, so that 2 multiplies 1 is 2, and 3 multiplies x is 3x. I hope it's clear. So in that case, this will still give us 2 over 3. 1 over x is the same, according to your indices, x to the power of -1. I hope it's clear. So we can write 2 over 3x to be 2 over 3x to the power of -1. I hope that is clear. The essence of doing this is to ensure that everything is in this form for us to be able to use the power rule. So we are done doing that. You see, the denominator has been removed to get this. So at this point in time, you can now differentiate. Okay, so in differentiating, we are going to have dy dx is equal to, according to your power rule, use the power to multiply. So we use this 2 to multiply 2. 2 will multiply 2, and 2 multiplies 2 will give us 4. So we're going to have 4x, take 1 from the power. 2 minus 1 will give us 1. And x to the power of 1 means x, according to your indices. Okay. Remember, this one has 1 already. So use it to multiply this. You know, any term without, any letter without a power is said to have a power of 1. So use the power to multiply. You have 1 multiplies 5 over 3. And when you multiply, it still gives you 5 over 3x. Then subtract 1 from this. 1 minus 1 is what? 0. So it means you are going to have x to the power of 0. And anything to the power of 0, according to your indices, is 1. So it means, and you know that 5 over 3x to the power of 0 means 5 over 3 multiplying x to the power of 0. And if this is 1, it means we are going to have 5 over 3 multiply 1 to give us 5 over 3. So it means we are going to have 5 over 3 as the value here. Okay, so what next do we need to do? Let's differentiate this. Use this power to multiply. It will now give us -1 multiplies this will give us -2 over 3x. Okay? Then remove 1 from -1. -1 will give us -2. I hope it's clear. Okay, let's simplify. We are done differentiating. Let's simplify it better. So we're going to have dy dx is equal to 4x minus 5 over 3. Because x is having a negative sign, it means that this x will come down. Okay? So this will give us -2 over 3 multiplying 1 over x squared. X has to come down because in your indices, the negative sign becomes 1 over. Then you bring down your x and raise it to the power of 2. I hope it's clear. So if you simplify further, you have 4x minus 5 over 3 minus 2 multiplies 1 is 2. 3 multiplies this will give us 3x to the power of 2. So this is what you get for differentiating this particular question. Please don't forget to subscribe to this channel. Let's know how you feel about what we are doing in the comment section. Like us and also share with your friends and family. But remember, we are not done. Remember, we are told this was what we were asked to differentiate. And I want to know, can we use power rule for this question? The answer is no. Why? We cannot use power rule here because can we express this to be in this form? Is it possible? Let's check. So this is what, let me bring this down here. What you have there is 6x to the power of 4 minus this all over 3x squared plus 1. Remember, if you want to express it to be in this form, you are dividing by the LCM. And the LCM here now is, you cannot use this. This is 3x squared plus 1. Can you use this LCM to divide each term? Let's see. Is this possible? Is this something that we can easily simplify? This cannot be easily simplified. So you see, when you have this kind of question, where the denominator is no longer a term, but an expression. Remember, the difference between a term and an expression is a term is one. Expression will involve two or more terms. So this has become an expression. So when the denominator is no longer a term, but an expression, please don't use power rule to differentiate. As you join us, you are going to see other techniques you can use in differentiating a function in this manner. I hope what we did in today's tutorial was well. So you see that this cannot go with power rule. Please don't forget to subscribe to this channel. Leave your thoughts with us in the comment section. Give us a thumbs up and see you in my next class. Bye-bye.